So now let's do trigonometry, which is question 5, question 6, and question 7. So let's start with the first one. It says point T is given on the diagram below. A is a point on the x-axis such that reflex AOT is equals to theta. So before you actually do anything, let's actually label the diagram or make it suitable to answer the question, right? So the first thing is you need to make sure that you create a triangle. So let's do that. So on the x-axis, right, go up, create a triangle that touches the x-axis always. It should not touch the y but the x-axis. Then label it. This part, this side is always what? It's always going to be the y coordinate. So in our case, it's going to be -2. Then from here to here, it's going to be -1. Then this is always r. And remember that r is always positive. So before you start, we need to find what's the value of r so that we can actually answer all the questions that they require us to answer. So let's do that. So finding r, we need to use theorem of Pythagoras because of this is a right angle triangle. R is your hypotenuse. So the formula is, so knowing that this is the formula, we're looking for r. So we're going to substitute r as being r squared. Then for x squared, we're going to substitute -1. Then for y squared, we're going to substitute -2. And r squared is going to give us, this is going to be equals to 5 when you simplify it, but we need r alone, not r squared. So therefore, r is going to be equals to the square root of 5. So this is going to be equals to the square root of 5. Then you're basically done with the diagram. Now we're going to use the diagram to actually answer the questions. So 5.1.1, it says we need to find 10 alpha, right? So 10 alpha is going to be what? Using this diagram, you know the fact that it's going to be equals to opposite over adjacent. What's our opposite? Our opposite is -2. Then our adjacent is this one, which is -1. Therefore, our answer is +2. So we're done with the first question. Then 5.1.2 says determine cos alpha. Cos is opposite. It's going to be what? Is adjacent. Sorry, not opposite, over hypotenuse. What's our adjacent? Our adjacent is -1 from the diagram. Then hypotenuse is going to be what? Is √5. So this will be your answer. Then number 3 says 5.1.3 says we need to simplify this, which is what? Which is cos alpha plus 40, right, degrees. Then this is an identity. I'll put a picture of the identity that I'm talking about, but the identity says alpha. And remember that all your identities are in the formula sheet. So what we need to do is we need to simplify this, right? So cos alpha, we already solved it. What was -1 over √5. Then this, when you punch it in the calculator, we know they said without a use of a calculator, but you can just punch it. It's going to be √2 over 2, right? Then sine alpha from the diagram is opposite over hypotenuse, so it's going to be -2 divided by what? Hypotenuse, which is √5. Then sine 45, it's a special angle, so when you punch it in the calculator, you're going to get, since they said without a use of a calculator, you cannot, I repeat, you cannot punch this whole thing inside your calculator. That shows the fact that you're cheating and you actually use a calculator. You need to what? Actually simplify it bit by bit. So the first part is that we're going to simplify this. So we're going to multiply numerator, and denominator to denominator. And when you do that, you're going to get -√2, not √5. Then √5 multiplied by 2 is going to be 2 √5. Then here, do the same thing. Negative, open a bracket, -2 multiplied by √2 is going to be -2 √2 divided by 5. √2 is going to by 2, not √2, it's going to be 2 √5. Simplify this side. The 2's are going to cancel out. So this negative and this negative is going to be a positive. So you're going to have, what do we see? We see the fact that this is the same thing, right? But the difference is that this has a 2. This 2 is the same thing as saying 1 over 2, -1 over 2, then saying √5 divided by √2 divided by √5, right? Plus √2 divided by √5. Since this and this are the same thing and this is a half, -1/2 plus 1, having this is 1 in front of it, is going to give you what? A +1/2. So your final answer is going to be what? It's going to be √2 divided by 2 √5. Then you're done with this question. Then now we're going to do 5.2. It says determine without using a calculator the value of the following expression. So this is the expression. So what I'm going to do is I'm going to make every trig ratio to have a degree of 20. So I'm going to change this 40 and use compound identity to change this one. 2 multiplied by 20 is going to give you 40. Then I'm going to change this one using reduction. So let me do that. You see the fact that if you say 180 minus 20 degrees, it's going to give me 160. So I'm still, everything is correct. And here 2 multiplied by 20 is going to be what? It's going to be 40. The reason why I'm doing that is that that's the only way I can solve this question without using a calculator, right? So after doing that, I'm going to simplify the reduction and I'm going to basically substitute the identity here. So let's do that. A negative, remember this, if we have sine, open bracket, negative x, it's going to be equals to negative sine x. So in knowing that, I can use it here. So this one is going to be negative 2 sine 20 degrees, right? So this one using reduction. So using this diagram below, the pink one, what I need to do is I need to check where 180 minus 20 is, which is theta is 20 in this case. So it's here in the second quadrant. And second quadrant, it says the fact that s is what? Is positive. So this one I'm going to reduce it, making s positive. So let's do that. Then the last one, we're going to use an identity. So the last one, I'm going to use an identity since cos 2 theta, right? Or 2x. And if you go down in the formula sheet, I'll put a picture on the side. It has 3 options. So I'm going to use the one that has sine. So it's going to be what? It's going to be minus, open bracket 1. So simplifying this front part, because of its sine 20 and sine 20, so it's both of them. So it's going to be sine squared 20. And now distributing the negative, it's going to be negative 1 minus what? Negative 1 plus, because a negative and a negative gives you a positive, plus 2 sine squared 20 degrees. The negative 2 sine squared 20 and this one are gonna cancel each other because it's gonna give us 0, making our final answer equals to negative 1. Now we're moving to 5.3. It says consider, then they give us like an expression, right? Then they say simplify the expression of the single trig ratio. So they want us to make this as expression to a single trig ratio. So let me write down the expression first. So now what I'm going to do is I'm going to change this 10 into an identity and I'm going to use reduction here. So first thing first, we're going to do what is we're going to change this 10 into an identity. Then here we're going to take out the square root outside. So let's do that. Then now we're going to use reduction to reduce this one. So we see the fact that we need 180 minus sine, which is the same as 180 minus theta. So it's here in the second quadrant. And sine is what? Sine is positive, meaning the rest of them is negative, meaning here our cos is going to be negative. So let's write it down. Then we're going to basically square this bracket since it's negative, and when we square it, this whole thing is going to be positive. So let's do that. Now what's going to happen is the cos here in the denominator is going to cancel with one of the cos here because it's 2 of them since it's squared. So now let me write it down, simplifying it. What do we see? We have cos x and sine x, and same thing, cos x and sine x. Here is 3 of them and here is 1. So 3 plus 1 is going to give you 4 cos x sine x. So they said we need to simplify it. So since they said we need to simplify it to a single trig ratio, you see the fact that this is an identity. I'll show the picture of the identity that I'm talking about. So if I take out 2 here and say 2 cos x sine x, it's exactly like the identity. So therefore this is equals to 2 sine 2x. Then we're done with this question. Now moving to 5.3.2, it says hence write down the range of f of x, which is this expression. So we know the fact that f of x, the simplified version from 5.3.1 is equals to 2 sine 2x, right? They want the range determined by what? Is always determined by the coefficient in front of the trig ratio, which is in our case is 2. So therefore our range is going to be y is an element of what? Of negative 2 till positive 2. Then this will be your range for this question. So now moving to 5.4, it says prove that the identity, then they give you the identities. So let's do that. So when proving an identity, we need to prove that the left hand side is equals to the right hand side. So you take the most complex one, then you simplify it to make it match with your other side, right? For this one, I'm gonna pick the left hand side. So I'm gonna pick the left hand side because I think it's the one that's more complex. So I'm gonna say left hand side is equals to, then I'm gonna write the left hand side. So seeing this is that I want to basically to some essence get rid of the denominator because of my right hand side does not have a denominator. Ne? So what I'm gonna do is I'm gonna change this into an identity. I'll put a picture on top, which is the identity identity is going to be this. So I'm going to expand this identity. Then what I'm going to do is I'm going to change this one and this one to its respective identities with this one. No, before I change this one, let me change this one because of this one has too many options. This one has too many options, so let me change this one first because I know the fact that it's going to contain cos, and if it contains cos, I can take cos as a common factor, meaning I can divide the numerator and denominator. So let's do that. And to be honest, when proving, it's all about trusting the process. It doesn't really look like you're getting to the answer as you proving, but just trust the fact that whatever you're substituting and you're picking the right substitution is actually working. Trust the process. Don't get discouraged. Just trust the process. So here we're trusting the process. So now what do we see? We see the fact that we have cos here and cos here. So we can take it as a common factor. So let's do that. So open bracket, we're going to be left with cos 2x minus a sine here and this one. So it's going to be the same as 2 sine squared x, right? Because it's sine and sine here. Then this whole thing. So the cos x and the cos x are going to cancel out. So you're left with cos 2x, and so you're going to be left with, so that's what I'm going to be left with. So the thing is, the nice thing that I'm seeing is that we actually slightly, but not there with getting with the answer, right? So we see the fact that our right hand side, always when you solve, refer to your right hand side because you need to know where you want to arrive to, right? We see the fact that our right hand side has what? Has a cos, right? So if we have to change this, because we know the fact that it has 3 options, we need to use the one that has a cos squared, right? So let's do that. Let's substitute this one with the one that has a cos squared. So it's the same as 2. So here, right, we know the fact that we have this identity. I don't know whether they put in the formula sheet, but it's sine squared theta plus cos squared theta is equals to 1. If I make sine squared theta the subject of the formula, I'm going to get 1 minus cos squared theta. That's good because of here, my right hand side has cos squared theta. So I'm going to substitute the sine squared theta by that. So now distribute the negative 2. Then if we group like terms, we're going to get, which is exactly like what your right hand side. And you're done proving this question. Now we're moving to 5.5. It says determine the general solution of x in the following equation. So the equation is one tip rule when you're dealing with the exponents. I know the fact that this is exponents of trig, right? But the minute you see 2 something, 2x, 2 to the power y, whatever it is, just know the fact that you need to use what? You need to use factorization to actually solve this question. So this is factorization I'm going to show you. So this is the same. If I take out the 2 outside and say, and this one, if I split it, then I'm going to take this 54 to the other side, which is going to be, so now what's going to happen is I'm going to take the 3, I'm rearranging everything. So I'm going to take the 3 in front. So it's going to be, so now what I'm going to do is I'm going to let 3 tan x equals to what? To k. Then wherever I see 3 to the power 10x, I'm going to substitute k. So let's do that. Do you see this is factorization? Then when you factorize this, you're going to get 2 brackets, which is going to be, then we're going to solve for k. Then we know that what k was 3 to the power 10x. So let's do that. Then this side, it was same thing. So this side, since it's negative, right, an exponent graph, if we had to say 3 to 3x, right, the exponent graph, it does not exist. This exponent graph, right, does not exist here. Since it does not have any negative y value, this is no solution. Now, meaning we have to deal with this one only. So let's do that. So this one, what we're going to do, we're going to change the 9 into an exponent. Then we're going to drop down the basis, right? Because they say they want the general solution. Then now we need to find the reference angle, which is equals to what? To arctan of 2. And our reference angle gave us 63,43 degrees, right? Then now we need to draw the cast diagram. So now when we're done drawing the cast diagram, we need to find where, since this 2 is positive, we need to go to the cast diagram and check where 10 is positive. Because of this one is the 2 is positive. So we check where the trig ratio 10 is positive in the first quadrant, and is also positive in the what? In the third quadrant, right? So the first quadrant is just theta plus k. So we're gonna say x is gonna be equals to theta plus k dot 180 degrees. Then you're gonna say k is an element of integers, right? So the period of 10 is 180. Just remember that, right? So we know that our theta, which is our reference angle, is 63,43. So we're gonna say x is equals to what? To to 63,43 plus k dot 180 degrees, then k is an element of integers, right? Or we know the fact that it's positive in the first and third quadrant. So the third quadrant says x is going to be equals to what? To 180 degrees, right? Plus theta plus k 180 degrees, where k is an element of integers, right? But we know that theta is 63,43, so we're going to say x is equals to 180 degrees plus 63,43 plus k dot 180 degrees, then k is an element of integers. But when we simplify this, our answer is going to be 243,43 plus k dot 180 degrees, where k is an element of integers. Then you're done with this question. So now moving to question 6. It says in the diagram the graph f of x is equals to, then they give us the graph of f of x, then they give us the graph of g of x are drawn in the interval between negative 180 till 90 degrees, right? So the first question, which is 6.1.1, it says we need to determine for which values of x from that interval that they gave us will f of x multiplied by g of x be greater than and equals to 0. So first we need to find the x-intercept. Only one that we have is here at negative 30. Those intercepts, the x-intercepts, are going to be our boundaries, right? Where maybe one graph changes from positive to being negative. So now what we're looking for when f of x and g of x multiply together gives us a positive, right? So when does that happen? When you multiply two graphs gives us a positive. Both graphs needs to be in the positive y-axis, or vice versa. Both graphs needs to be in the negative y-axis, because of a negative multiplied by a negative gives us a positive. So in our situation, we're looking for we're looking when one graph is, both of them are in the positives, because when you multiply a positive and a positive, it gives you a positive, and they said greater than, right? So we're looking for positive, or we're looking for a situation when we have a negative multiplied by another negative, it's going to give me a positive, right? So we're looking for those both situations. So now let's underline where f of x and g of x are greater than, right? Meaning we're going to underline the top part. We're going to underline here, because of that's where y is positive, because this is positive y-axis. So this is where we're looking at it, right? So as I said, the fact that we need to look at either both graphs are positive or either both graphs are negative. Where are they both positive, right? They are positive here. Let me change the color. They are positive. From C here, from the intercept that I talked about, both graphs are positive. Do you see that? Both graphs are positive. But you see, before that, before negative 30, do you see the fact that one graph f of x is positive and the other one is negative, right? So a positive and a negative gives you a negative. So since they are both positive here, our answer for the first question is going to be what? It's going to be x is from what? It's from 30, negative 30, the boundary that I talked about, till our last part, till 90 degrees, because that's where it ends. That's the restriction that they gave us, till 90 degrees. So this will be your first answer for the first question. Now 6.1.2, let me erase this. It says we need to find g of x is equals to negative 1. So here in our graph, we need to check where it's negative 1, and we need to give the values of x, right? So we know the fact that this is going to be negative 1. So I'm going to draw a line going through here. So let's do that. So see, I drew a line by negative 1, because if they say g of x is equals to negative 1 and g of x is the same as y is equals to negative 1. So we need to find values where those y is equals to negative 1, right? So going from the graph, I'm going to draw. Do you see the fact that here at negative 60, going down, let me do it in pink, from negative 60, if we go down like this, do you see the fact that even here at negative 180, you see? So our two values is going to be what? It's going to be x is equals to negative 60 degrees, right? Or here, x is equals to negative 180 degrees. Then you're done with this question. So now moving to 6.2, it says the y-axis is moved 90 degrees to the right. So we know the fact that the graph is going to move 90 degrees to the right, right? If something basically is affecting left and right, think about x. If they say a graph moves up and down, your immediate thought is that it affects y. So in our case, this, because of it moved 90 degrees to the what? To the right, it's affecting x, right? Meaning x is equals to what? Is equals to 90 degrees, and it's positive. So since it's x is equals to 90 degrees is positive, we need to change it so that we make this side into being a 0, so we can substitute into the formula, right? So we know the fact that we have f of x in our case being what? Being negative cos sine plus 1. That's what we know, right? And as I said, the fact that if it moves to the right, x is equals to a positive value, right? And if it moves to the left, x was going to be equals to negative 90, but now it says to the right is positive, right? So if it's positive, we need to change this so that we can substitute it here in the formula, meaning we need to take the 90 to the other side. So it's going to be x minus 90 degrees and is equals to 0. Then we take this and we substitute it here. So let's do that. So f of x now, the new one is going to be equals to negative cos, here it's going to be x minus 90 degrees. Then this is going to be plus 1, right? Then they say the fact that we need to simplify it to its simplest form. So let's do that. We're gonna use co-ratio here. So we need to change this 90 to come in front. So it's gonna be cos, then it's gonna be negative 90 plus x degrees. Then now what I'm gonna do before I do that, I'm gonna take out a negative as a common factor. Remember this, if we have cos negative x, it becomes what? It becomes positive, so it's going to be cos x. So this is going to become positive, so keeping the negative outside. So taking this diagram, we want 90 minus x, which is this one, which is in the first quadrant, meaning cos is going to be positive, but since it was already negative, this one is going to be still negative, so it's going to be negative. Since this is a co-ratio, cos changes to sine, so it's going to be sine x plus 1, and this will be your final solution. And yes, I've seen it. If you do watching this video with reference to the memo basically made this a positive. That's incorrect. If this is a positive, if you say x plus 90, you basically say that the graph moved to the left hand side, which is completely wrong. When it moves to the right, it's x minus 90. It can be a positive, it needs to be a negative, right? So you can double check with your teachers, or you can even reference to the notes. Where something moves to the right, inside it becomes positive, here in the bracket becomes negative. But if it moves to the left, this bracket inside becomes positive. So that's what I wanted to talk. I'll put a picture on the memo, or while I'm talking, I probably had a picture basically discussing that. So now moving to question 7, it says the diagram BCD, which is the gray part, is the horizontal plane. Then they tell us that AD is the vertical pole of the two cables, right? Then it says AB and BC, right? So it says the angle from B and C to A, the top of the pole are theta, which is they gave us a label there, and to theta respectfully. Then they say AB is equals to 5 units and AC is equals to x unit. So the first one says we need to show that x is equals to 5 divided by 2 cos theta. So what can we see? We see the fact that our let's show has what? Has x, right? Which is x is here in the diagram, and it also has 5, which is here. Then it has theta, so it has theta. So what can we see? The fact that what can we use, or what do we see? We see the fact that there's two triangles, which is I'm gonna draw the first one, which is I'm gonna highlight this one in purple and the other one with blue. What do we see between triangle purple and triangle blue is that they both right angle triangle, meaning we can use what? Trig ratios, right? And 2 is that they both share AD as being a common side. So I'm going to use that common side to arrive to the 7.1. So let's do that. So the first one, I'm going to deal with the purple circle, right? It says I need AD and the hypotenuse to be inside my answer, right? Because I need 5 in my answer and I need theta. So it's going to be AD being common, it's going to be opposite, right? It's going to be opposite over hypotenuse, so it's going to be sine theta, because the angle is theta, is going to be equals to what? Opposite, which is AD, which is the common side, divided by 5. Then I'm going to make AD AD subject of the formula because of it's the common side, so I can equate them together. So it's going to be 5 sine theta, right? Then I'm going to move to the white, to the blue circle. So it's going to be AD is the common side, so it's opposite. Then I need x, which is hypotenuse, so it's going to be sine here 2 theta is equals to opposite, which is AD, divided by what? By x. Make AD subject of the formula, so it's going to be x sine 2x is equals to AD. Equate, this is equals to AD. So equate AD and AD, so it's going to be 5 sine theta is equals to x sine 2x. So in our question, we see the fact that they made x subject of the formula, so let's do that. So we're going to divide both sides by sine 2x, so it's going to be 5 sine theta divided by sine 2 theta, not 2x, 2 theta. 2 theta is going to be equals to x. So x, here I'm going to change the denominator into an identity. When I change it into an identity, it's going to be 5 sine theta divided by 2 sine theta cos theta, right? The sine theta and the sine theta are going to cancel out, therefore making x equals to 5 divided by 2 cos theta. And I've answered the first part. Then the second part, they say calculate the length BC, which is here, this one in green, right? Then they say the length of BC, if you are given that this angle here, right, is equals to, let me do it in a visible color, this angle here is equals to 112 degrees, and we want this, right? And they tell you that theta is equals to 30 degrees. So the one that I'm thinking about is that since we given this side and this side, I can solve it because of we have the angle theta here. The only thing that I need the angle to find x is the angle only. If I have two sides and they want the remaining side, I can use what? The cosine rule. So using the cosine rule, we need an included angle and two sides that are on the side of the angles, right? So the cosine rule in this case is going to be BC, so 7.2 is going to be BC squared is equals to AB squared plus, right, AC squared minus 2AB AC, then sine of the included. So this angle and this part needs to be opposites of each other. Sine of A, right? So what do we have? We have all the properties here. First, let me solve what's x, which is this side. So I'm going to do it in pink. X is going to be equals to 5 2 cos 30 degrees. Put that into your calculator. You're going to find it as being 5 divided by 5 root 3 divided by 3. So that's going to be your x. So let's substitute. BC is going to be equals to what? AC, AB. AB is 5. Then this one is x, AC, which is x, is going to be 5 root 3 divided by 3 minus. Then simplify this, punch this whole thing into the calculator. You're going to find BC squared to be equals to 44,15 square root the side, both sides, so BC is going to be equals to the 6,64, and you are done finding the length of BC.